All right, hello. My name is David Barreto. I'm a developer advocate for Starknet. And my goal today is just to explain you like the interesting bits about Starknet in 30 minutes, hopefully with some time for questions at the end as well. So I'm going to cover, first of all, the motivation of why Starknet, then a little bit about the programming language that you use for smart contracts called Cairo, a discussion about some of the features of Starknet, what makes it unique, some of the tools that you can find, especially as a developer, that you might find useful, and some discussion about the present and future of Starknet. All right, so first of all, why do we even bother to create Starknet? So if we look at the scaling problem of layer one, when you have a block producer that takes transactions, executes them, and proposes a new state for Ethereum, for example, new state 42, all the nodes of the network is just they're not gonna trust that value is correct. What they're gonna do actually is just take the same block, the same transactions, and re-execute them independently over and over. So every single node on the network is gonna do that. So as a result, even a simple computation, simple transactions, actually consume a lot of processing power for the whole network because of all the re-execution to validate the result. In the case of Starknet, and in the case of many of the rollups, the idea is that now we will have, it's a sequencer, that is the one that's gonna do the execution of chain. And in the case of Starknet, not only is gonna give you what the new state is gonna be, it's also gonna generate a cryptographic proof that attests to the validity of the computation. So now that when we send the proof down to layer one for verification, all the nodes on Ethereum are gonna verify that cryptographic proof. But as you can see, the amount of the effort that it takes to verify a proof is only a fraction of the computation required for the execution. So as you can see, the whole system is more efficient. So the question is, how much efficiency did you gain using validity proof, like in the case of Starknet? So if you have some kind of computation, for example, executing multiple transactions, and that computation takes n steps done by the sequencer, then the verification, the thing that is done on layer one, it's actually polylogarithmic, so log square of n. And it's easier to see the comparison with these two charts. So the blue line, it will be the underlying computation, and the red line will be the effort for the verification of that computation. So the bigger the gap between these two lines is what we gain in performance of the network as a whole. So I think that I want to do the comparison that validity proofs are to computation what the zip algorithm is to file size. It's a type of compression. Just in the case of validity proof, it's a compression of computation, when for zip it's a compression about a file size. So let's go a little bit deeper into validity proof. First of all, it's an implementation of zero-knowledge proofs, or ZK proofs. And we use it to guarantee what's called computational integrity. And a way to think about computational integrity is this phrase, doing the right thing even when no one is looking. So in the case of Ethereum, you guarantee computational integrity just by re-executing over and over, and guarantee you get the same result. In the case of Starknet with Cairo, you guarantee that through the ZK proof, through the validity proof. So in the case of Starknet, we use ZK proof not for privacy, and that's a common misconception. We use ZK proof for scaling Ethereum, for throughput. So that's why we think that ZK rollup is kind of like a misnomer, because ZK rollup implies some kind of a privacy. But really, in this case of Starknet, we use ZK proof for scaling, so we like the term better, validity rollup. Finally, a feature of Starknet is that we use Stark proofs and not snarks. So you probably have heard about a snark before and not that much about Stark. So this is a comparison between the two cryptographic proofs. So in the case of Stark, as I mentioned before, verification compared to the underlying execution is polylogarithmic, while in the case of a snark, it's constant, so it doesn't depend on how complex the computation is. In case of the proof size, the thing that we send from layer 2 to layer 1, in the case of a Stark, it's in the ballpark of 400 kilobytes, while in the case of a Snark, it's actually pretty small, like hundreds of bytes. So you might be wondering, okay, so Snark looks pretty good, much better than Stark. Why did we bother to actually use Starks for a Starknet? And the reason is twofold, right? In the case of when you use a Stark, you don't need to have a trusted setup. In the case of systems that use a snark, they need to go through a ceremony to feed the system with a secret, and the secret needs to be properly disposed, otherwise the system can be compromised. So for a Stark, there's one less thing that you need to trust that has to go well for the system to be secure. And also, I think maybe even more important, Stark proofs are considered to be quantum secure because the only cryptographic primitive that is used is actually the hash function. In the case of the Snark, they are not quantum secure. So that is a thing to keep in mind whenever quantum computers become sufficiently powerful to start to be, let's say, a source of concern for layer 2s. Okay, so we talk about Starknet. Now let's talk about the programming language that you use to create smart contracts on a Starknet. And that language is Cairo. So as you might have heard, we don't use Solidity. Our system is not a CK EVM. We use a Cairo VM. So right now, the language that is supported today on Starknet is called Cairo 0x, or Cairo 0.10 to be more precise. And when you have a smart contract in Cairo 0, when you compile it to the Cairo assembly, right? This is what the Cairo VM can execute. The limitation that we have in Cairo 0, and because that was the first iteration of the language, is that we can only create validity proofs for executions that succeed. If we have an execution that fails, we cannot generate a cryptographic proof out of that. So that is a limitation of Cairo 0. That's why we are working on developing a new iteration or a new version of the language. So Cairo 0 was created in 2020, which is quite a while in terms of rollups. To my knowledge, was the first provable programming language to get to mainnet. And interesting, it can be used actually outside the blockchain. So there might be some use cases that I'm not aware right now, but you can actually use it outside of a Starknet. But it has some limitations. Being the first iteration of the language, one of them is that it's a low-level language. And because it's also low level, it has a steeper learning curve, right? You have to understand some of the details how the virtual machine actually works to understand some feature of the language. And as I mentioned, you cannot generate proof for failed executions. And that is problematic because a sequencer will not be compensated if they try to execute a transaction that ultimately fails. And this is basically a vector of a denial of service attack that we are very well of. So that's why we developed, before I go to Cairo 1, let me show you how Cairo 0 looks like. So this is a simple example of a smart contract that you can deploy today. I don't want to go into too many details because it's going to be replaced by Cairo 1, but just so you have an idea, this is how you declare this file to be a Starknet smart contract. This is how you import functions with a syntax similar to Python. So the language was inspired, at least the syntax, from Python. This is how you define contract storage using decorators or annotations. So it annotates some functions. In Cairo, we have the native data type is called felt for field element. You can think of it similar to an integer. You can have constructor functions who are called during deployment. In this case, in Cairo 0, you can only have one constructor per file. This is another feature of the language that you can have actually implicit and regular arguments. Implicit arguments is a way to have higher performance for computations who are actually complex to do on CK technology. But these implicit arguments are actually going to go away on Cairo 1, make it a little easier to understand the code. You can see that every function has to have a return statement. Then you define functions that are going to be view-only or external. So in the case of the view-only function, this is the one that you can are read-only. So when you call them, you don't have to pay gas fees. But in the case of the external functions, this is the one that modify the state of the smart contract, and that's why you actually have to pay gas fees when you execute them. So this is Cairo 0.10. As I mentioned, we're working hard on the new version of the language, trying to learn from all the lessons of using Cairo 0 in production for quite some time. So Cairo 1, one of the biggest changes is that, first of all, it's a high-level language. So it's much easier to learn. And you're going to have to, because it's inspired by Rust, at least syntax-wise, if you know the language or you're familiar with similar languages, you're going to feel at home with Cairo 1. Also, it gives you some strongly typed guarantees. And now the language, when you compile it, it doesn't compile directly to Cairo code as before. It compiles to an intermediate language that we call Sierra. And Sierra stands for Safe Intermediate Representation. And that is basically what allows now that every execution, doesn't matter if it succeeds or if it fails, now we can create a validity proof out of that. So as a result, now we can have transactions that can be reverted in a way that the sequencer is always compensated by the work, even if the transaction fails. So no more potential DOS vector. And this is how a smart contract in Cairo 1 will look like. So if you're familiarized with Rust, you're going to see a lot of the similarities. You can do some meta programming with attributes. That's how you define this code to be a smart contract. This is how you bring functions into scope to define storage variables for this smart contract with a struct. Failed, it's still the native data type of Cairo that hasn't changed. But now we have additional data types that are natively supported. For example, U256, which is commonly used on Solidity or in Ethereum, or contact address for addresses. This is how you will write to storage, and how would you read from it. And now when you define a new variable in the smart contract, now there's only one way to define that using let. In Cairo 0, we had like 4 different ways to define a variable. Now it's much simplified with just let. So as you can see, it's a much higher level language, easier to learn, and is inspired heavily by Rust. So because now we need to go through this transition, right? We have to move on from Cairo 0 to Cairo 1. So the plan is to do it basically in 2 steps. So we have one event called the Starknet 0.11 release to mainnet. So before that happens, the only programming language supported by Starknet is Cairo 0.10. And that's where we are right now. But we are very close to release Starknet 0.11. And at that point, we're going to be able to support both programming languages, Cairo 0 and Cairo 1. So this is going to be like our migration window. So we provide a mechanism for builders to migrate their smart contracts from Cairo 0 to Cairo 1 while preserving the address of the smart contract and while preserving the state. So for the end user, will be a transparent migration. But at some point in time, maybe a couple of months later, we're going to go through regenesis. And in regenesis, we're not going to remove Cairo 0, actually, that's a mistake. We're just going to disable Cairo 0 contracts. Because as I mentioned before, Cairo 0 cannot, if you execute those smart contracts and it fails, you cannot generate a cryptographic proof out of that. So we need to avoid that from happening in the network. So after regenesis, only Cairo 1.0 smart contract will be supported. So it will be very important for developers to use the migration window to migrate in time to the new version of the language, because after regenesis, those smart contracts will be, you cannot execute them anymore. So after regenesis, now we have full guarantee that the network is not susceptible for any type of denial of service attack. All right, so let's talk about some of the features that are unique to Starknet. So let's start with the architecture. So on a Starknet, when you send a transaction, you actually send the transaction to the sequencer. So the sequencer is one of these off-chain nodes that has to execute the Cairo VM, but also has a module called the Starknet OS. So out of the execution, so the sequencer is going to take all the transactions. They're going to create blocks for layer 2, and it's going to execute those transactions. And as a result of the execution, it's going to generate what's called an execution trace that is sent to the prover, another module of Starknet. And this prover is actually called SHARP, because it stands for shared prover. So the prover is the one who creates a validity proof out of the execution done by the sequencer. And this validity proof is sent to Ethereum as a transaction, right? And it's sent to a smart contract called the verifier. This is a Solidity smart contract. So the verifier is the one that takes the proof and actually verifies. And the result of that verification is registered in this other smart contract called the fact registry. So this is the one that you can query to see is a particular validity proof that correlates to certain transactions or certain blocks on layer 2 has been successfully verified or not. And after the proof has been verified, then Starknet is going to send changes in the layer 2 state to layer 1, to the Starknet core smart contract. And this is the data availability layer of a Starknet, or how a Starknet uses Ethereum as the data availability layer. Of course, this might change a little bit once EIP 4844 comes along, but right now, this is how it works. So now the full nodes for Starknet. Right now, they actually sync the state from the sequencer. But the idea is that because you can derive the same data. You can derive the current state of layer 2 of Starknet from the Starknet core smart contract, because all that information has been set as cold data to Starknet core, so you can parse that information and recreate the state. So that is a escape hatch in case everything fails on layer 2. You can always recover what the current state is from Ethereum itself. So let's start to recap some of the modules that discussed. So we have the sequencer that validates, executes, and bundles transactions into blocks. Then we have the prover that creates Stark proofs for Starknet and StarkX. StarkX is another service that created by Starkware. So the prover that we have actually serves two things, Starknet and StarkX. We have the verifier, which is a Solidity smart contract that verifies the Stark proof from Sharp. We have the fact registry, another L1 smart contract that stores the result of all the verifications. A Starknet core, which is another smart contract that receives changes to the layer 2 global state as cold data. This is the DA layer. And finally, we have the full node that provides data to layer 2 decentralized applications. Another interesting feature of Starknet is account abstraction. And to explain account abstraction, let's start with Ethereum, how it works. So in Ethereum, we have two types of wallet. We have the regular wallets, we call the externally owned accounts. And then we have smart contract wallets, right, that we can use, for example, for multisigs. And the big difference between these two types of wallets is that only externally owned accounts are considered to be first-class citizens on Ethereum, while the multisigs of the smart contract wallets are not. There are things that you can only do with EOAs that smart contract wallets cannot do. And that's a shame, because smart contract wallets, the power to create a wallet using a smart contract gives you plenty of flexibility. So on Starknet, every single wallet is actually implemented as a smart contract, and we call that the user account. And as a corollary of this change, now we have decoupled the signer from the thing that holds your assets, performs validation of the signature, that is a user account, and that is a smart contract that you can program to your needs. So this gives you a lot of flexibility. For example, you can use different elliptic curves to sign your transactions. And now, because this is the only way to create a wallet, this type of a smart contract wallets are first-class citizens. These are able to do anything in the network. So benefits of account abstraction. One of my favorites is that now you can use your smartphone dedicated hardware for cryptography, because now we can support any type of elliptic curve for signing transactions. So we can make use of the elliptic curve of your iOS spatial hardware, or Samsung, or Android, which gives you physical isolation from shared system in your smartphone, so extra security. It has a stronger random seed for private keys. It has secure storage of those private keys on your phone. And you can sign transactions using hardware, so it's hardware accelerated. So all these benefits are only possible because of account abstraction, and because you can now program exactly how you want to validate transactions of your wallet. It also enables social recovery of accounts, or session keys for gaming, so you don't have to sign every single transaction while you're gaming, so a much nicer user experience. You can have things like automatic fraud monitoring. So for example, when you try to interact with a malicious smart contract, if you have that enabled, it will alert you, it will prevent you from falling trap of a scam. You can have spending limits for on-the-go keys, and multi-calls. This is an interesting one. Now you can sign multiple transactions all at once. Another feature is the time to finality. So if we compare, we have the two extremes, right? So we have Ethereum, in about 6 minutes you have finality to epochs. On the other end, you have optimistic rollups that takes a week to have full confidence, especially when you withdraw assets. In the case of Starknet, it takes From the moment you send a transaction to the moment the validity proof gets verified on layer one, it takes about 10 hours. So it's a big win compared to what optimistic rollouts can offer today. And interesting, this number, these 10 hours, might go lower the more traffic that we get on layer two. Because one of the reasons to wait 10 hours is just to have enough time to bundle enough transactions to make the verification cheap enough for all the transactions included in the block. So the more transactions we can send in a block in a shorter time, it just makes it financially viable to make it cheap layer 2 transactions. So other features, I just mentioned here, we have a trustless bridge that allows for smart contracts on layer 1 and layer 2 to communicate with each other. And this is how bridges are being built. We have optimistic parallelization. So the sequencer is one of the first focus of improved performance. So this feature allows you to parallelize transactions as much as possible unless you find collisions of storage. We have also implemented recursive proofs because proving or creating the proof is a very intensive computation. So recursive proof allow you to keep the hardware specs of the prover low while still being able to bundle a bunch of transactions on a single proof. So if you're here, you might be a developer, and if not, some of the tools might actually be useful for you. But to give you a taste of the ecosystem for Starknet. First of all, we have two main wallets on Starknet. One of them is Argent X that you can use as a browser extension. The other one is Bravos that not only has a browser extension, they also have the mobile wallet that makes use of what I mentioned about account abstraction. You can use the dedicated hardware of your phone as a signer. So now you can sign transactions with Face ID or with your finger. We have two different block explorers, Voyager, and we have Starkscan. So to pick which one you like the most. And some tools for development, we have one called Protostar, which is similar in principle to what Foundry does for Ethereum, the fact that you can test Cairo smart contracts using Cairo. And then Open Zeppelin, they also they have a library of reusable smart contracts in Cairo that you can use. And they actually have a wizard as well to easily, with a UI, create smart contracts like ERC20s or NFTs in Cairo. Cool. So let's talk about some of the work that's been done right now to improve Starknet, some of the things that are planned for the future as well. Let's talk about the decentralization roadmap. So in the case of the sequencer, today it's a centralized node. It's operated by Starkware, and it's written in Python. So what we're working on right now, first of all, is to do a full rewrite of the sequencer in Rust and do it open source. So now you can go check it out, the repositories and the work that's been done. And we do that rewrite module by module. And the first module to be open source and be available is called Blockifier. We're also working in the consensus mechanism so we can have multiple sequencers working in tandem as well. So that's being researched right now. In the case of the full nodes, right now we have actually 3 different clients for Starknet: Papyrus, Pathfinder, Juno, all of them open source. And as I mentioned today, when they want to sync to get the latest state from layer 2, actually goes talk to the sequencer directly. What is being worked on right now is to implement a P2P network so these nodes can talk to each other and can synchronize from each other so they don't depend on the sequencer to get the latest state. In the case of the prover, right now, again, centralized, controlled by Starkware, but we have made a commitment to open source the prover as well. And this probably is going to be the final piece of the decentralization effort of Starknet. In the verifier, the last piece is completely open source. It's just a Solidity smart contract that you can find on Starkware's GitHub repository. So that's where we are right now, where we are going. We also set up last year the Starknet Foundation, created in November 2022 as a non-for-profit. It has a board of 7 members. And the goal is to make Starknet a public good, right? We want to make Starknet as useful to as many people as possible, similar to what Ethereum offers now. The foundation holds more than half of the initial supply of the Stark token. And token holders can vote or delegate their vote to decide on protocol changes. So whenever we want to improve the protocol, improve Starkware, that has to go through voting from the foundation. And finally, the voting is going to be done like a regular with Snapshot, which is a very popular tool for this purpose. I mentioned that we want to Rustify everything. We use rewrite because the whole stack was initially written in Python. So it was great using Python to validate, Stark proofs and how it works. And actually, the concept works pretty well, but it's slow, right? Python is an interpreted language. So the rewrite of Rust in Rust is led by this company called Lambda class. And the first target to rewrite is the sequencer, as I mentioned before. And actually, an important module of the sequencer is the Cairo VM itself, the thing that executes Cairo code. That's called the Cairo RS. And initial estimations of benchmarks of comparing the Cairo VM written in Rust versus the Python one, the Rust one is 20 times faster than the current version today, and it uses 12 times less memory. So you can see how much improvement we get just by switching to a new language. And this is just the first iteration of the Rust implementation. It will also improve over time. We also have a project called Scarp. It's a play on the word Scarab. And Scarp is a package manager for Cairo 1. And it's inspired by Cargo, used by Rust. It's created by Software Mention. And it's going to be used for Starknet smart contracts and also for vanilla Cairo programs. As I mentioned, you can use Cairo on its own outside of the blockchain. And the goal is to be open source and extensible. That's it. That's in 30 minutes all I can tell you about Starknet. Thank you very much. I have 2 minutes for questions, if you have any. Question there.
Hi, thank you so much. So with when you say you can call multiple calls, I'm just kind of curious how many you can do. I'm typically, I can understand this through state transitions, so I understand that maybe there's a limit on how many calls you can do. When you say that you can do multiple calls.
Oh, for the multiple.
Yeah, can you allude to how many you can do? Yeah.
So yeah, at some point the layer 2 blocks, they will have a limit of how many computations you can include in a single block. I don't know the number, but I recall seeing there's a game that is actually able to do 52 transactions in a single swipe. So that's a huge improvement. But I don't know the exact number of how many, because a transaction depends on how complex the computation is, right? 2 transactions, I don't know, sending Ethereum is simple compared to try to execute, I don't know, an AI model on chain. So it depends on the complexity. But as I mentioned, now, today, we have that example, 52 transactions in a single, executed as a single transaction, really. Any more questions? Okay, if not, yeah.
Just one last. Is this the same implementation that Zcray or zkBNB or other EVMs use for their layer 2?
Well, Cairo is not EVM. It's not a CK EVM, right? Because we have our own language, Cairo, and we have our own VM, the Cairo VM. So it's an apple to oranges. We make the decision because we think about the long-term performance gains. If you have a language that is fully optimized for validity proofs, it's something that you cannot do. Some performance gains you cannot have when you have a CK EVM that is optimized for compatibility. So that was the trade-off that we made initially. But I cannot make that comparison. I really don't know. Question here? This will be the last question because we don't have more time.
Hey, thanks for the talk. Is there any ZK features that I can use with Cairo? Because it uses ZK for compression.
Yeah.
But I want to know if I can actually use the language to express CK. Like, for privacy, if I want to build a dApp, can I use that using Cairo?
You might need to wait probably until the prover is open source.
Okay.
Because when you can run your own prover, you can do things like fractal scaling. You can actually create your own layer 3
Right.
in a permissionless way.
Okay.
So that will be possible when we get to the decentralized
Okay.
layer.
So something like a Peterson hash, do I have access to it using Cairo 2? Sorry, Cairo 1?
I believe so.
Okay,
Yeah.
cool. Thanks.
All right. Thank you very much.